I'm Jake, and let me show you a picture of something. That is the tardigrade, also known as the water bear, also known as the toughest animal on Earth. And it's not big, it's between 0.3 and 0.5 millimeters, about 20 to 30% the thickness of a US penny.
So tiny.
And it's pretty small, but don't be fooled, they can survive immense amounts of radiation due to the protein that they have called DSUP that prevents X-ray damage better than our DNA can. And in fact, they're one of the few animals on Earth thought to be able to survive a nuclear bomb, and that's what this episode is all about. If we could survive a nuclear blast. So get ready for some nuclear dongs, things that you can do online now, guys. You may be familiar with NukeMap, a site that allows you to simulate the destruction caused by a nuclear bomb in a given area. Well, Outrider.org has created a version of that site that allows you to simulate the scope of damage in a much more visual way. First, type in a zip code or address and you can choose between 4 different types of bombs ranging in size. The lowest energy one is the 15 kiloton Little Boy used in Hiroshima during World War II in 1945. It was the first atomic bomb ever used in war, and you can see that its damage would be pretty far-reaching if dropped here in Los Angeles. The fireball spreads 0.07 square miles, the shockwave is 1.55 square miles, radiation is 2.18, and heat is 3.44 square miles. And that's just the results of a surface blast or a ground burst. Now let's look at the results from an air burst, which the Little Boy was. Not only have the fatalities more than doubled, but the injuries have almost tripled, and the effects of the shockwave and heat are much larger. So while surface bursts produce more radiation and larger fireballs, air bursts produce more heat and a larger shockwave. So why was Little Boy detonated around 2,000 feet above Hiroshima? Well, because bigger shockwaves can destroy a larger area in a shorter amount of time, and it's made possible because of something called the Mach stem. First, there is a shockwave from the explosion, then a second shockwave when the first one bounces off the Earth's surface. The two combine to create a more powerful wave, the Mach stem. Surface burst bombs don't have this effect and also tend to shorten the reach of shockwaves due to the buildings and other structures getting in the way, in a sense, dampening it. But the fallout from a surface blast or a ground burst is much larger. I mean, it detonates directly on the ground, so it ejects all this debris like dirt and dust and cement and what have you into the air that become radioactive due to the explosion. And this creates fallout, which can spread and be blown by wind for thousands of miles. And I talk all about fallout actually on Vsauce 3 in a video, Could You Survive Fallout, if you want to learn more specifically about that. And even though the effects from this debris are greater with a ground burst, the consequences of fallout from an air burst are still devastating years after the initial detonation. For example, Little Boy was estimated to kill 70,000 to 80,000 people with the initial blast. But when the bomb was dropped to 5 years later, an estimated 120 to 130,000 more people were killed due to radiation. Now, let's go back to Outrider to look at the largest nuclear bomb ever detonated, the Tsar Bomba, weighing in at 60,000 pounds. Now, this is the damage caused by the Little Boy if it were a surface blast or a ground burst, and this is the damage that would be caused by the Tsar Bomba. The simulation estimates it could kill 2.6 million people, about 500,000 more than the population of the entire state of New Mexico. Now, to get a better understanding of the inner workings of atomic bombs, let's check out the simulation on nuclear fission. Simply put, fission is when a heavy and unstable nucleus is split in two. And it's important to note that in real life, creating atomic bombs requires the fissioning of trillions of atoms. But this isn't real life, and your computer probably can't handle that kind of simulation. So the idea of this is to adjust the factors in such a way that you cause a chain reaction that will fission all of them. The red dots represent uranium-235, one of the most common isotopes used in atomic bombs. When you click a dot, it will fission and cause the others to do the same. But with the default settings, you won't likely get all of them. So let's check out some of the factors. Whether or not you add a neutron reflector can have a big effect. Now, the neutron reflector directs atoms back to the fissioning core as opposed to letting them escape and get lost. A useful feature is the show splitting atom animation. Without it, it can be difficult to follow the chain reaction, and it's crazy to think that this reaction is what causes craters like this. Ground bursts tend to cause deeper and narrower craters than air bursts. But what about subsurface bursts? Well, depending on the depth of burial, they can cause pretty deep craters. Let's take a look at ecodemo.org, which shows 7 different craters caused by nuclear bombs. Not all bombs are created to be weapons of war. In Kazakhstan, Lake Shagan was made as a result of testing out explosives to form artificial lakes in 1965, but it's probably not a good idea to swim in or drink the water from it since it is still radioactive 50 years later. I mean, fish don't live in it and mammals don't live near it. And that is only one of 7 craters on this site with information like purpose of detonation, location, and size. Some of the biggest craters on Earth weren't even made by atomic bombs or man-made at all. They were created by things like meteorites or asteroids crashing in to Earth. Now, to simulate this, head to Crater Impact, where you can choose the projectile diameter, trajectory angle, velocity, projectile density, and target density. When you get to the map, click on an area for it to strike and you'll see just how big of an impact it can create. The largest one is the Vredefort crater in South Africa. It struck about 2 billion years ago and released more energy than any man-made bomb ever. In fact, it is thought to be the largest single energy release event on Earth. It made a crater that was 190 miles across and almost 10 miles deep, 10 times deeper than the Grand Canyon, and would take you over 3 days of non-stop walking to cross. But a really cool feature is that it allows you to compare the depth of the crater to things like the CN Tower, the Empire State Building, or Big Ben. And Wikipedia has a map of 190 confirmed impact craters that show you where on Earth it is, the size, and its age. I hope this episode isn't kind of a downer, Dong. I don't want that to be the case. I just find nuclear bombs to be incredibly fascinating and also incredibly devastating. It's hard to think about the actual impact and the size of them when we see videos like this. We don't get the scale of it. We don't understand fully when watching this the effects of radiation or fallout on people or places that could be impacted for years or even generations. So anyway, there you go. Enjoy that little nugget. And if you want, there's more videos about nuclear fallout and just nuclear bombs in general down there for 2 Vsauce free videos I made. I'm gonna go, but I want you to know that I love you and that I appreciate you and that Hannah loves you as well. Right, Hannah? That was a kissing noise. Either that or like a balloon, kind of. That was a kiss? Oh, that was a kiss. Well, there you go. You got a kiss by Hannah. That's rare. I don't know. Okay, and as always, thanks for watching.